Welcome guys. Today's topic is Fajans Rule. As we know, a covalent bond is not 100% covalent and an ionic bond is not 100% ionic. Then how do you know a bond is ionic or covalent? Guys, we learn about dipole moment which can determine ionic character in covalent bond, and in Fajans rule we will go to know about covalent character in an ionic bond. Actually, we can't calculate the percentage covalent character in an ionic bond, but we can calculate the percentage ionic character in a covalent bond in dipole moment. Actually, Fajans rule is based on deformation or polarization of ions. How does it happen? Let's understand with a picture. The cation having high polarizing power and attracts the electron density from the anion and creates a overlapping zone. Thus, polarization takes place and covalency introduces. Now, ionic potential is the ratio of charge of the ion and radius of that ion, and which cation have more ionic potential, that is charge by radius, possesses more polarization, because with increasing the ionic potential, polarizing power of the cation increases. More polarizing power of the cation, that means more covalency and less ionic character. Now, melting point or boiling point for covalent bond is less than ionic bond, because melting point and boiling point for covalent molecule is the required energy to break the weak van der Waals force of attraction, whereas melting point or boiling point for ionic bond is the energy required to break the strong electrostatic force of attraction in cation and anion aggregate. The cation having pseudo noble gas or 18 electron configuration possesses more polarizing power than noble gas or 8 electron configuration, because 18 electron configuration contains 10 d electrons and d orbital have diffused shape, and due to low shielding power of d orbital, effective nuclear charge of the cation increases and size decreases. So size is smaller of 18 electron cation than 8 electron cation. Now guys, with increase in covalency, the bond getting loses its dipolar character. Thus, solubility decreases in polar solvent like water and increases in non-polar solvent like carbon tetrachloride. And with decrease in covalency, solubility increases in polar solvent and decreases in non-polar solvent. Let's understand this with an example. Solubility order of silver halides in water or polar solvents: AgF greater than AgCl greater than AgBr greater than AgI. Here the new thing is the cation is same, so we can't say about covalency by using polarizing power. Here covalency depends on polarizability of the anion. Polarizability means the tendency to be polarized, and polarizability increases with the size of the anion, that is I minus greater than Br minus greater than Cl minus greater than F minus. So increases in polarizability, covalency increases. So thank you guys. Thanks for watching.